Hello everyone, welcome back to Let's Crack JEE English, the channel of Unacademy. And I am Jeetendra Dixit. Here is my profile. So I did my BTech from IIT Kanpur and I have been mentoring IIT-JEE aspirants for last 11 years. Just a moment. Okay, so let me check my voice first. Okay, so let's continue. So I started sequence and series in previous session, and we were discussing arithmetic progression. I have told you about sequences and progressions and series. So the difference between progression and sequence, and also what is series. So and we started arithmetic progression, which is in the syllabus, and I told you about arithmetic progression, and geometric and harmonic we'll do later, and arithmetic or geometric progression and some other progressions also there. And we'll find the sum of series in the syllabus, which series which are in the syllabus of IIT-JEE. All right. So all these series, but today we are going to do the sum of the series. We'll form the series of arithmetic progression. All right, and we'll find the sum of that. All right. But before the beginning, let me tell you about Unacademy subscription. So as you know, Unacademy is India's largest online learning platform. And once you get the subscription, you can prepare for many exams on this platform. But let us talk about IIT-JEE. So if you prepare for IIT-JEE and you get the subscription, then these are the things you get. Let me explain these things. Now, first of all, you get access to daily live classes of all the educators. All means all physics, chemistry, and maths. All right. You can attend sessions of educators of your choice. This is free. This is allowed. So you have that freedom. You will get unlimited access. All right. Unlimited means all the educators who are teaching on the platform for IIT-JEE, you can follow them. All right. Second thing, you can attend special classes. So special classes are free. That means you can attend all these special classes on the platform on Academy, uh, and this you can attend without getting the subscription. And after attending these special classes, you will come to know about the platform, how to interact with your educator, the different features of the platform, right? So these classes are very interactive. So just attend a special class and you'll come to know. All right. So special classes, I'm repeating, are free. All right. So, and also quiz feature is also there on the platform. So there you can attend quizzes also, like special classes. So whatever quiz is planned, you can attend that quiz on the platform. That is also free. But live test and quizzes you get when you unlimited live test and quizzes on the platform, PCM types. Those tests you get when you subscribe to Unacademy Plus. So all the courses on Academy Plus are well structured. That means everything is pre-scheduled. So you get to know the schedule of the all the upcoming lectures in well advance. So you can accordingly plan your sessions. Even if you miss something, then you can watch recorded lectures also. So recorded lectures of all the educators will be available to you. So you can watch unlimited recorded lectures. All right. So that feature is also there. So you get unlimited freedom as well as unlimited access. All right, once you get the subscription. Now Unacademy is learning app you can download from Play Store, and after downloading it, you can get the subscription for 1 month, 3 months, 6, 12, and 24 months. All right, 12 and 24 months you can see are now 38,500 and 56,000, and after 10% discount you'll get 34,650, and this will be 50,400. All right. So this is the subscription charges. You can use my code JEET1 to get instant 10% discount. Okay. So you'll get after discount, it will be 34,650. And these two packages, 1 year and 2 years package, are the economically best packages. So you can buy these packages, and new price list is out. This is from 10th of September. All right. So after 10th of September, now this is the new price list, and you can take subscription by paying this much for 1 year and 2 years. All right. Okay, guys. So get the subscription if you haven't taken it yet. Now let's begin the session sequence and series. So today we are going to do some of the series, sum of arithmetic progression. So your AP is, say, the first term of AP is A, first term of AP is A, and common difference is D. All right. Then you know how to, and sum of n terms you are writing by Sn. So it will be A plus D plus A plus 2D and so on. And second last term will be A plus n minus 2 into D, and your last term, nth term, will be A plus n minus 1 into D. Okay. So this is the summation of n terms, and we need to find the value of this. So let's see how to find it. We are going to use the property. I have told you one property in the previous session, that first sum of first plus last is equal to second plus second last, and third plus third last, and fourth plus fourth last. So all these terms are equal. First plus last is equal to second plus second last is equal to third plus third last, right? This is very simple to understand, because you can see that in first term, second term, when you write second term, D will be added to the first term. And when you're writing n minus second last term, then D will be subtracted to the first term. So first plus last will be equal to second plus second last. So what I'm going to do in this is just flip this series and write it again. So if you flip a series, suppose you're writing 1 plus 2 plus 3, and then you write 3 plus 2 plus 1. Then after flipping the series, summation will remain same, right? So you can use that. So let's write it again. So last term I'll write first. So it will be A plus n minus 1 into D. Okay, plus, this is the last term. Now this will be second last term, right? So write second last term, A plus n minus 2 into D, and so on. Okay, and then third last, and so on. This will be the second term. Now A plus D, after flipping the series, and first term will become the last term. Now add these two series, and you will have to use this. See, you will get this. A1 plus an is equal to A2 plus an minus 2. This property is going to be used in this. All right. See how? If you add them, so this left hand side will be 2Sn, and if you adding these two terms, first, so it is going to be now 2A plus n minus 1 into D. All right. This is first plus last. Now add these two terms, second and second. So if you add these two, it is going to be again 2A plus n minus 1 into D. So all the terms now will become 2A plus n minus 1 into D. Okay, if you add these two terms, this will also become 2A plus n minus 2 D and D. So this is n minus 1 into D. And the last term is also 2A plus n minus 1 into D. So how many terms are written? Obviously same number of terms which you have written earlier also. So this is now first term, this is second term, this is third term, and so on. This is n minus 1 term, and this is n term. So now all terms are equal, and you have n terms. Suppose you are adding 2 plus 2 plus 2 plus 2 10 times. Then what will be the answer? 2 into 10, right? If you are adding 3 plus 3 plus 3 100 times, then what will be the answer? 3 into 100, right? So similarly, in this way, you are adding this term to n times. How many times? N times. So if you're adding this term, this same term, suppose if I call it B, then B plus B plus B plus B plus B n times. So that will become n into B, right? Hello, Dhruv. So that will become n into 2A plus n minus 1 into D. All right. You always come, say hello, and leave, Dhruv. Sn. So now you can write, now you can see Sn is going to be, Sn is equal to n by 2 and 2A plus n minus 1 into D. So this is the formula for sum of n terms of NAP. Sum of n terms of NAP. This can also be read, you can read this formula as n by 2. You can see this was first plus last, right? So you can split it again and write this a1 plus, okay, a plus n minus 1 into d. Okay, so this is your first term and this is your last term, right? So you can write this formula as this what is this quantity? This quantity can be written as a1 plus an, or a2 plus an minus 2, right? Or a3 plus an minus 3, and so on, right? So you can read this formula as n by 2 first term plus last term. All right, so sometimes we apply in this form also, n by 2 number of terms. If you know number of terms, first term and last term, then you can apply this formula, number of terms divided by 2 into first term plus last term. All right, even if you know second term and second last, then you can use here second plus second last. That means you can read this formula as n by 2 second term plus second last. Second last will be an minus 1th term. All right, so you can use this formula as well, right? So now two forms, I'm writing it again. So Sn you need to remember in this way, Sn, sum of n terms of a series of an arithmetic progression whose first term is a and common difference is d, is n by 2 2a plus n minus 1 into d. Okay, so this is the formula. This is the formula we have derived. Or you can read n by 2 first term, okay, first term plus last term. All right, like this also. In fact, you can replace it by second term, or second term plus second last. Similarly, third term, third last, fourth term plus fourth last, right? Say unlimited way you can write, right? So I hope you have got this. One more thing I want to tell you about this. If you see this sum of n terms of NAP, if I expand it, we need to use this formula, and we will remember in this form only. But I am writing it in another way to tell you something, okay, about this. So when I wrote the rth term of an arithmetic progression, I told you that rth term is a linear function of r, right? It was like dr plus, if you remember, it was dr plus a minus d, right? So it was a linear term of r, like 3r plus 4. That is a if rth term of a sequence is 3r plus 4, then it is an arithmetic progression, right? Similarly, nth term, sum of n terms of an arithmetic progression, if you see, is basically quadratic in n. If I expand it, after expanding it, it will be n into a plus, it will be n square into d by 2 plus minus d by 2 into n. So you can read this as d by 2 into n square plus a, take n common, so it will be a minus d by 2 into n. So you can see this sum of n terms, first n terms, okay, sum of n terms of an arithmetic progression is always of a n square plus b n type, right? B n type, where a is equal to, if you compare, then a is what? Where a is equal to d by 2. So by comparing, you can find a also, right? By comparing, you can find common difference also. Okay, like if sum of n terms of an arithmetic progression is given 3n square plus 4n, then immediately you can tell the common difference. Common difference will be 6, because 3 is equal to d by 2 and d is equal to 6, right? So, and also you can tell, even if he is not telling you that this is the sum of first n terms of NAP, if he tells you that sum of first n terms of a series, all right, of a series, or a sequence, sum of first n terms of a sequence is 3n square plus 2n, all right, then which series is this? Okay, this might be a question. And if he tells you that if it is NAP, then find the common difference. If it is a GP, then find common ratio, right? So by looking at the formula that it is quadratic, an square plus bn type, immediately we can say that this is the sum of NAP, right? This is because this is an square plus bn type, right? So immediately we can say this is sum of NAP. And what will be the common difference? Common difference of AP you can write immediately. Okay, this is Sn is given. All right, so common difference is this a by d by 2 is equal to 3, so you'll get d is equal to what? D is equal to 6. All right, and you can write first term also. What is first term? First term is nothing but S1, right? So first term is S1. So you can put 1 in this, you'll get the first term. So by putting n is equal to 1, you'll get first term as 5. So first term, you have got first term, you've got the common difference. Okay, so now you can now you can answer any question, right? Even if you want to write the sum, then you can write it again and you'll get 3n square plus 2n. Okay, you can check that. So I hope it is clear, right? So I have written the formula of first n terms, sum of first n terms in this form and in this form, right? And in this form, 3 forms, okay? So 3 forms. This third form is something like you are not going to use it to apply to find the sum. To find the sum, you are going to use either this one or this one, okay? This will be for some other questions like sum is given and then you need to compare it, okay? Sum of n terms is given and then you need to compare it. Then you can answer it like if it is an square plus bn type, then it will be sum of n terms of NAP. So I hope you are getting this point. I hope it is clear. Now let's begin some practice session. Okay, practice questions. So this is the first question. If SR denotes the sum of R terms of NAP, then we need to show that S of 3R minus S of R minus 1. That means S of 3R. What is this S of 3R? This is sum of 3R terms. Sum of first 3R terms, right? Because he has given us the definition that SR denotes the sum of first R terms. So S3R plus S3R will denote the sum of first 3R terms. SR minus 1 will denote the sum of R minus 1 terms, right? Similarly, S2R will denote the sum of 2R terms. So you can write it easily, right? So let's assume let first term of AP is equal to A, and common difference, let's take D, all right? So let's take common difference D and first term A. Then we can write let's write these terms, okay? S of 3R, S of 2R, S of R minus 1, S of 2R minus 1, and after writing it, we can put in the formula. Or directly you can start with the formula. Start with this given expression, S of 3R minus S of R minus 1 divided by S of 2R minus S of 2R minus 1. So I am going to put the values of these summations in this expression only, all right? So what will be S of 3R? If I apply that formula, then it is number of terms 3R divided by 2, okay, multiplied by 2 times of first term 2A plus number of terms 3R minus 1 into common difference. Into common difference is D, all right? So this is the value of S of 3R minus S of R minus 1 will be R minus 1 by 2, all right? And again open it. So it will be 2A plus R minus 1 minus 1. So it is going to be R minus 2 now into D, all right? So I hope you are getting it. Plus, divided by. Now let's put the values of the terms in denominator. So in denominator it is S of 2R. So S of 2R will be 2R by 2 and first 2 into first term plus 2R minus 1 into D. Okay. Keep putting the values and later we'll simplify it. It should be 2R minus 1. So that means everything will get cancelled. Now let's write S of 2R minus 1. So S of 2R minus 1 will be 2R minus 1 divided by 2. Okay. And 2A plus, it is now 2R minus 2 into D. All right. Okay. Now let's simplify it. So how to simplify it? First of all, you can cancel this 2. Okay. So cancel this 2. Okay. Now see if anything is common. So seems difficult if anything is common. No, there's nothing common. So that means we'll have to open it first. Okay. Okay. So let's open it. Multiply this 3R inside. Okay. This 3R inside and this R minus 1 inside. So I'll club also simultaneously. From first and first, I'll get 6AR. And from this 2 has got cancelled. From this I'll get 2. Okay. let's take this and this term common, okay? So 2a common, and it will be 3r from here, from this 3r, and minus r minus 1. Minus why? Because you can see minus sign in between, right? So minus r minus 1, so that is going to be r plus 1, all right, like this. Now let's club these two terms, this and this. In this you can take d common, right? So let's take d common, and after taking d common, you can see it is going to be 3r into 3r minus 1. So that is 3. Okay, let's write 3r into 3r minus 1 first of all, or you can expand it. So it will be 9r square if I expand it simultaneously. Okay, so it is going to be 9r square. Are you getting this? This will be multiplied to it. So 9r square minus 3r, all right. Now this r minus 1 will be multiplied to r minus 2, right? And minus sign is there. So if I multiply r minus 1 and r minus 2, it will be r square. Then you'll get minus 3r, so that will become plus 3r, and plus 2, so that will become minus 2 because of the minus between these two terms. Okay, because of this minus, all three terms will change their sign. So this is the numerator now. This whole divided by. This whole is divided by. Now we need to do the same process in the denominator also. So it's a little subjective type of question. Okay. So let's multiply. Let's take this. Let's multiply club these two terms and these two terms. So you can take 2a common. So after taking 2a common, what are we getting? See this. This will be 2r, and it will be minus 2r minus 1. So minus 2r plus 1. All right. Plus d times of. So d times of, now multiply 2r to, this was 2r minus 1. So it will be 4r square minus 2r, and 2r minus 1 will be multiplied to 2r minus 2. Okay, and we need to open it as well as we need to change the sign of all the terms because of this minus. So minus, let me write it. So you will get 2r into 2r, so 4r square. So I'm writing 4r square. Okay, then you will get then you will get what? Okay, so 2r into minus 2r, so that will be minus 4r and minus 6r. So minus 6r and minus of plus 6r, all right, plus 6r. We are very close, just about to finish. Minus 1 into minus 2 is plus 2, so it is going to be now minus 2, all right, minus. This is now done. Just need some calculation is remaining, so let's finish it fast. Now it is going to be 2a into 2r plus 1 in the numerator plus. Now let's simplify this also. This is going to be what? 8r square. So d into 8r square, and minus 3r plus 3r will get cancelled, minus 2, and you can take 2 common also. So if you take 2 common, it will be 4r square. Okay, because it was 8r square, 2 you are taking common, so it will be now 2r square, 4r square. 4r square minus 1, all right. 4r square minus 1 divided by, it is not 2a only. You can see 2r and 2r will get cancelled, and plus d times of, see now it is so simple. 2r and 6r, this 4r and 4r square will get cancelled. 6r minus 2r is 4r, and this minus 2 will be there. So 2 in this also you can take common. So by taking common 2, it will be okay. Now you can see 2r plus 1 is common in the numerator. So take 2r plus 1 common in the numerator, and it is going to be 2a plus 2d into 2r plus 1, this thing, divided by, it is going to be 2a plus, if you take d2 common, it will be 2 times of d into 2r minus 1. So you can see this numerator and denominator, these two terms are same, so they will get cancelled, and remaining is nothing but 2r plus 1. So now this is your answer, hence proved. All right, so we needed to prove that this ratio is 2r, and we have proved it. Now let's move to another problem. There is also subjective type, so we'll start some basic problems first. This is an important problem. You try it for a minute. You need to use a property which I have told you, which actually we used while deriving the formula also, right? Sum of first plus last, second plus second last. So this is a hint, okay? This is a hint. Use that hint to find the sum. All right. So try this one. See if you are getting any answer. Then I'll tell you in a minute. So, oh, hello Subhash. Yes. Okay, you are getting D. You have got the answer D. All right. So let me solve it for you. By the way, D is the correct answer. Using the property, you have 24 terms here. So you can write A1 plus A24 is equal to A2 plus A23 and so on. You can use A5. A5 is the fifth term. Fifth term and fifth last. Which term will be the fifth last term? Fifth last will be 24 minus 5 plus 1. That is 20, right? So A20 is the fifth last term. And that is also equal to 10th term, A10. And 10th last will be 24 minus 10 plus 1. So that is 15, right? A15. Okay. So we are going to use this. So that means A1 plus A24 is equal to A5 plus A20 is equal to A10 plus A15. And what is given in the question? We are given that A1 plus A5 plus A10 plus A15 plus A20 plus A24 is equal to 225. So you can club these two terms, pair first and last, pair this and this, pair this and this, right? So you can write 3 times of A1 plus A24. 3 times of it is, you can convert this into first plus last only. That means it will become 3 pairs, 3 equal pairs. So 3 times of first plus last is equal to 225. And from this you'll get A1 plus A25, A24, sorry, A24. And that is going to be, if we divide by 21, so it is going to be 75. All right. Now you need to write the answer of first 24 terms. So what will be the answer? You can apply sum of first 24 is 24 by 2, first plus last, the same formula because now you know the first plus last. So directly use it. It is 12 into 75 and that is going to be 900. All right. So this is one way. You can also do it like assuming first term in common difference. So just assume first and common difference, put all the values A1, A5, A10, A5 and you'll get a relation between A and D. Use that relation to find the sum of first 24 terms. That relation will directly be used. All right, directly you can use that relation. So that is another way. So this is a smart way of doing it. If you know if you can figure it out that it is first plus last, second plus second last, so directly use it. So let's discuss this one. This is another good problem. So I'll tell you first. Try this one. See if you are getting the answer. These questions are important for JEE main. This year also, like the exams which are just finished of JEE main, there were questions from GP and AP. Simple questions. Hi Sashi, how are you? Try this sum. See if you're getting the answer. All right, if you're not getting, then let me do it. See, if you assume the first term of ratio of n terms of two ABs, so first term of first AB is A1 and common difference. Let's take common difference as D1. All right. Similarly, your first this is of first AB. Similarly, for second AB, take first term as B1 and common difference as D2. All right. So it is given that ratio of n terms, first n, ratio of sum of first n terms of both the ABs. So if you write the sum of first terms, sum of first n terms of first AB, that will be n by 2, 2A1 plus n minus 1 into D1. This is the sum of, divided by sum of first n terms of second AB, that will be n by 2, 2B1 plus n minus 1 into D2. This is given. This ratio is given 3n plus 8 divided by 7n plus 15. You can see number of terms are same for both the ABs. So this n by 2 will get cancelled, right? Now what is required? You have only one relation given and you need to find, I mean, you have four variables. So do not try to find the values of the variable, okay? You won't be able to find, because one from one relation, you can find only one value. And there are four variables, A1, D1, B1, D2, right? So do not try to find the values, you won't be able to. That means you will directly get the value of the expression which is required. So first write that expression which is required. So what is required? You need the ratio of 12 terms of both the sequences. That means you need A1 plus 11D1, 12 term, divided by B1 plus 11D2, okay? So this is what is required. A1 plus 11D1 divided by B1 plus 11D2. So now compare it. If I take 2 common from this and cancel it, if you take 2 common from the numerator and 2 from the denominator, it is going to be A1 plus n minus 1 by 2 into D1 divided by, it will be B1 plus n minus 1 by 2 into D2. It is given in terms of n, 3n plus 8 divided by 7n plus 15. Now look at this carefully. It is true for all values of n, right? It is true for all values of n, this ratio, this one. So that means you can put any value of n in this. Let's put such value of n so that this numerator this becomes coefficient of d1 and coefficient of d2. They are same, so they will become same whatever value I put of n in this. So if I put such value of n for which n minus 1 by 2 becomes 11, right? Then I'll get this expression directly by putting that value of n in this, and right hand side I'll put the value, same value of n, and I'll get the answer, numerical ratio, right? So what should be the value of n for which n minus 1 by 2 will become 11? So you can find it easily. Solve this equation. So n should be 23. That means put n is equal to 23 in this. N is equal to 23 in this equation. And now it will be converted to A1 plus 11D1 upon A2 plus, B1 plus 11D2. And what is the answer? Now put 23. So 23 into 3 is 69 plus 8, and 23 into 7. 23 into 7. So it is 161. All right, plus 15. Okay. Now add this and let's cancel whatever is cancelling. So it is 76 divided by 1. This is 176, right? 176. So 76 divided by 176. Now check it. What is the answer? So if I cancel it by all right, let's cancel it by 2 first. So after cancelling it by 2, it will be 38 divided by Seems there might be some, because 7 or 5, is it possible? No, 7, 5 not possible because they are not divisible. Let me check the calculation again. 3n plus 8 and 3 7n plus 7n plus 7n plus 15. So oh sorry, this is 77. I'm sorry, 77. That's why you were negative. Okay, now you can cancel it by 11. All right. So that was 77. By mistake, I have written 76. So now it will be 11, if you cancel it by 11, it will be 7 upon, and if you divide this by 11, it will be 16. So 7 is to 16, right? So answer is 7 into 16. So B is the correct option. All right. Now let's try another problem. This is pretty simple. Try this one. Sum of the numbers lying between 10 and 200, which are divisible by 7. Try this and try to get the answer. Sum of the numbers lying between 10 and 200, which are divisible by 7. So first check how many numbers are there which are less than 7 and are of less than 200 and of multiple of 7. So first check those numbers. So if you divide 200 by 7 and take greatest integer, that means integral part. So just divide it by 7. So it is 2 28 plus 4 by 7. You can write like this, right? So check it. I think it is correct. 28. Yeah. Okay. So this is the so you can see 28 terms. This is the integral part, 28. So there are 28 multiples of 7 less than 200, right? 28 multiples. Last term will be 28 into 7. You can check what is the last number, 28 into 7. Check it, it should be 196, right? 196. So 196 is the last number divisible by 7. All right. Now see how to do it. Now one number is not there. Which number is not there in this? Because you are starting from number more than 10. So 7 is not there in these 28 numbers, right? So total how many numbers? Your first number is starting with 14, then 21 and so on, right? Up to 196. If you take 7, then total numbers, how many numbers are there in this sequence? Total in this sequence you have 28 numbers, all right? 28 numbers. But if you leave 7, then how many numbers will be remaining? Now numbers remaining will be 27 numbers. Okay. So now you know the first term also as well as the last term and number of terms. So you can find the sum easily, right? So sum is equal to 27 by 2. 2 first plus last, do it first plus last. So 14 plus 196. All right. Simple. So it is going to be 210. So 27 into 210 divided by 2. Okay. So first it is going to be 27 into 105. Okay, so we can eliminate easily that 7 into 5 is 5. So your first unit place is going to be 5, right? So unit place is going to be 5. You can use that because only one option has unit place as 5. So you can answer this, all right? Obviously, you can calculate, just multiply. It should be 2835. It will just save 10 seconds, not more than that. Okay, so you can multiply it. It is going to be 2835. All right, so let's move to another problem. Now this is again a very, very good problem. Try this one and I'll tell you the answer. Sum of odd numbers is given. Sum of first n odd numbers. So if you need to remember it actually. Sum of first n odd numbers, all right? Odd numbers is equal to n square. Okay, we can apply the formula because this is an AP only. So because this is an AP, so we can obviously apply the formula and we'll get the answer. So sum of first n odd numbers is n square. Remember this point, all right? Like we remember sum of first n natural numbers is n into n plus 1 by 2, right? So in that way also you can remember sum of first n odd numbers is n into n is n square. And what is the sum of first n even numbers? Sum of first n even numbers. Starting from 2 obviously, even in positive. Okay, positive, let me add this positive. Okay, even natural numbers. Okay, even natural numbers, that will make it perfect. In this also let me add natural numbers. All right, so that is going to be if you know if you add 2 plus 4 plus 6, then 2 you can take common, it is going to be 1 plus 2 plus 3 up to n. So that is n into n plus 1. All right, n into n plus 1. So this is sum of first n even numbers and this is sum of first n odd numbers. All right, this is not difficult. Obviously you can apply this formula. Sum of first n odd numbers is n by 2, 2a, so 2a is 2 into 1, right? 2 into 1 plus n minus 1. What is the common difference? Common difference is 2, so it is going to be n by 2. Now inside you can see it is 2 plus 2n minus 2, right? 2 and 2 will get cancelled, so it is 2n only. 2n into n by 2 is what? N square. It was so simple, right? But why should we waste time in this? Because this is very useful and it is used a lot, right? The sum of n odd numbers, whenever we see, we can apply it n square. So in this you can see SP is going to be what? SP is sum of first p odd numbers, so that is going to be p square. Sum of first q odd numbers is going to be q square, and sum of first r odd numbers is going to be r square. All right, so yes, your answer is correct, both of you, Sakshi and Subhash. Your answer is correct. Well done. So it is going to be p square plus q square is equal to r square. Okay. Now we need to find the smallest value. So PQ and R are natural numbers, right? Positive integers. So what are the smallest numbers which satisfy Pythagorean identity? That means Pythagorean triplet, smallest numbers. So you all know that 3, 4 and 5. This is the smallest Pythagorean triplet, right? So if I take P is equal to 3, Q is equal to 4 and R is equal to 5, then P plus Q plus R will be least. So you need the smallest value of P plus Q plus R. So P plus Q plus R minimum should be 3 plus 4 plus 5. Okay. So that is going to be 12. So 12 is the correct answer. Done. Now next, let's move to another problem. Now this is another problem. Try this one. Now in an AP of which A is the first term, and if sum of first P terms is 0, sum of first P terms is 0, then we need to find the sum of next Q terms. Sum of first P terms is 0, then we need to find the sum of next Q terms. Alright, so try it. Try to find the answer. Okay, so Sakshi, you are getting B, and Subhash, you are getting C. All right. Okay, let me solve it for you. See, whenever you have sum of, like in this, if I represent sum of first n terms as Sn, then Sp is given 0. Sum of NAP, whose first term, which A is the first term, sum of first P terms is given 0. So SP is given 0, and we need to find the sum of next Q terms. So sum of next Q terms is basically sum of first P plus Q terms, because if sum of first P terms is 0, then sum of first P plus Q terms will be equal to sum of next Q terms, right? This is same as sum of first next Q terms after P terms, right? So basically, whether you find sum of first P plus Q terms or sum of next Q terms, both will be same. And using this, you can use first term as A. If you'll go to find sum of next Q terms, then you'll have to find the first term of that series. That will be basically P plus 1th term. So do not do that. That's not required. You just write the sum of first P plus Q terms. So I hope it is clear to you, because you guys have answered this. So I'm assuming that you have got it. So sum of SP plus Q is our answer, and that is P plus Q by 2. All right. And 2 times of A plus P plus Q minus 1 into D. All right. But we need to use that sum of first P terms is given 0, because answer is not in terms of this. So we'll use that sum of P terms is 0. So what will be the sum of first P terms? It is P by 2, 2A plus P minus 1 into D is equal to 0. So D is not given, so we need to find the value of D. And from this you can find the value of D. So P minus 1 into D is going to be minus 2A. All right. So we'll put the value of D in this equation. In fact, let's put it here. So it is going to be P plus Q by 2. All right. Into 2A plus P plus Q minus 1 into D is nothing but minus 2A divided by P minus 1. All right. This one. Simplify it. 2A is common. So if you take 2A common, 2 will get cancelled. It will be A into P plus Q. And in denominator it is P minus 1. Also take the LCM of P minus 1. So it will be P minus 1 minus will be there, because it was minus 2A. So minus will be there in between these two terms now. So it is minus of P minus of Q and plus of 1. All right. So minus P will get cancelled and 1 will get cancelled. And yes, so answer is minus Q times of A into P plus Q divided by P minus 1. So whose answer is correct? It is B. So yes, Sakshi, your answer is correct. Subhash, you did the mistake. Minus, you missed minus sign somewhere. All right. So I hope it is clear. Try this next. This let me check if you have. All right. Okay. Try it. This is a good problem. Okay. Try this. This is a very good problem. Natural numbers are divided into groups. First group has one number, next second group has two next natural numbers. Third group has three next three natural numbers. Fourth group has four numbers and so on. Nth group will have n numbers. And you need to find the sum of that numbers in nth group. So sequence is basically same. I mean, in nth group also numbers will be in AP. They are natural numbers, consecutive. You just need to figure it out. Then which number is basically uh, which is the first term in that group and what is the last term in that group. All right. If you come to know that, you can do it easily. Getting something? Na, 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 na. Oh, both of you. AA. Have you done it completely or you use some elimination method? Generally, students do that. They take some smaller number of n and they put it and check. So using that, you can eliminate options, yes, but you should learn the method also. Have you done it completely, guys? Okay, see, let me tell you the method. If I write these numbers, 1, 1 in the first group, and then 2, comma 3, then you have 4, 5, 6, and so on. Then there will be n minus 1th group, right? And there will be nth group. I don't know what is this number. Let's say this number is last number is AP. That means total numbers used up to nth group is equal to P. So we can find the value of P, right? And total, and let's see this number is Q, AQ. Total numbers used up to n minus 1th group. Okay. So we can find AP. We can find P easily. P is what? Total numbers used in all n groups. Okay. So total numbers used in n groups. Because suppose if 5 numbers are used, if 5 numbers are used, then it will be 1, 2, 3, 4, 5. Then what will be the next number? 6, right? If 3 numbers are used, you can see if 3 numbers are used, first two brackets, in first two groups, only 3 numbers are used. So what is the next number? 4, right? So P we can find. P is nothing but 1 plus 2 plus 3 plus 4, right? one number is used in this, two numbers are used in this, three numbers are used in this, p numbers, n numbers are used in the last one. So total numbers used is n into n plus 1 by 2. All right. Now what is q? Total numbers used in n minus 1 groups. Total numbers used in n minus 1 groups. See, why am I finding this p and q? I'll tell you why. So that is going to be, just put n is equal to n minus 1 in this, all right? So it will be n minus 1 into n by 2. Now see, what do you need? You need the sum of all the numbers in this group. So what I am going to do is, let's take this sum as s, all right? So s is nothing but sum of all the numbers in all the groups. How would you find it? Because these are nothing but natural numbers, 1 plus 2 plus 3 plus 4 plus 5 plus 6. If you add all the groups, if you add all the numbers of, I mean, all the numbers of n groups, then it will be just, you need to apply the formula of p into p plus 1 by 2, right? Right, p into p, because total numbers, how many numbers are used in n groups? P numbers, so last term will be p, okay? So it is going to be p into p plus 1 by 2. Let's take this p, let's take this q, don't get confused. All right, so it is going to be p into p plus 1 by 2, right? P into p plus 1 by 2, okay? And minus sum up to this term, so that will be q into q plus 1 by 2, right? You know the values of p and q, so put in this. So if you put the value of p, that is n into n plus 1 by 2 into n plus 1 by 2 plus 1, all right? And this whole divided by minus 1 by 2 of n into n minus 1 by 2, all right? And again put in this n into n minus 1 by 2 plus 1. So that is one of the way. You could find first and last term also. See if anything is common. See, obviously you can take n common, n is common, n is common, and this 4 is common. So n by 4 at least take common and write the remaining terms. So multiply it inside. It will be n into n plus 1, and take LCM also. So total 8 you can take common. It is going to be plus 2 into n plus 1, all right, this thing, okay, minus from this n is already n you have taken common, multiply this n minus 1 inside. So it is going to be now n into, I missed something, it was n plus 1 whole square. So n into n minus 1 the whole square plus n into n minus 1 the whole square plus n minus 1, all right, this one, and 2 also, 2 times, okay? So now this n by 8 is common. Now club this and this, all right? So by clubbing these two and this, you can simplify it easily. So actually it is going to be 2n plus 2, and last is going to be 2n minus 2. So it is going to be 4n, all right? So I'll write that 4n first, plus you can take n common from this and this as well, right? So take n common. So after taking n common, it is going to be n plus 1 the whole square minus n minus 1 the whole square. And you know what is this value? This whole is multiplied to n by 8. Some calculation is there. So let's finish it. This a plus b whole square minus a minus b whole square is basically 4ab, right? So if you write this, it is going to be 4n plus n into 4n, right? So n into 4n. Now almost, okay, I'll write it here, n by 8. Okay, I'll write it here. So it will be n by 8 now, and 4 you can take common. In fact, 4n you can take common. So 4n is common, all right, and it will be 4n is common. So n plus 1. So what is the answer? So answer is actually n square by 2 into n plus 1. Okay, let me just check the calculation once more. Yeah, seems perfect. No, okay, I've done one mistake. Yeah, that's why it was coming. This is basically plus 2n and this was minus 2n. So not, it won't be minus 4n, it will be 4 only. Yeah, that was an error. It will be 4. 2n will get cancelled, it will be plus 2 and minus 2. So 4 will be there only, not 4n. There's one correction. Let me correct it. Yeah. Now it is perfect. So answer will be different then. What is the answer? Let me write it again. So answer is now, you can take 4 common, so 4 will get cancelled, n by 2 and it is n square plus 1. Yeah, so actually yes, A answer was correct. Okay, so I hope it is clear. So A was the correct answer. Alright, so we'll continue. I'll start geometric progression next, and some more difficult problems we'll do later from arithmetic, geometric and harmonic. Once we'll finish all these sequences, then later we'll add lot of sequence, lot of series. So far it was good. I mean, I have covered all the basics. So you can start doing problems based on arithmetic progressions. Tomorrow I'll start geometric progression. All right. Then first I'll finish all the progressions, all the series, and later we can do some difficult problems also. All right. Okay, guys. So complete it. Like the channel and like my videos.